So your test, this is the last 9 weeks, of course, and then spring break is next week, and you've got Monday off. So we're going to finish the notes today and tomorrow. Tomorrow in class, you'll be working on a practice test, that kind of thing. If you don't finish it in class, it'll be due for homework. But it'll give you an idea what the test will look like. The test will be on Wednesday. Wednesday. We'll grade them overnight, Mrs. Richter and I. And then we'll go over the test in class on Thursday. And if you fail the test, then you got Thursday after, or you got Thursday and Friday. You will have failed if you see your grade Wednesday night. But you got Thursday morning, really Friday morning. You got Friday. I guess we can do Friday in class too if you need a retest. Because Friday, I'm not sure what we'll do. We'll probably just try to finish the notes. Thank you.
So is there another quiz tomorrow as well?
Yeah, 6 minutes. Tomorrow, 6 minutes. If you take same thing, just 10 trig functions. If you want to take tomorrow's and at the regular time and you make 100 on it, we'll count that as backwards if you missed it. Okay.
Okay.
Yeah.
Oh, so if I take it tomorrow, I won't have to make a Friday quiz.
Right. If you go tomorrow and you make 100 in 6 minutes, we'll count that as your 8-minute quiz and your 10-minute quiz. Yeah, because it works backwards. If you make 100 in 6 minutes, I know you can make 100 in 8 minutes. Yeah. All right. So here's example 8. Your free response question will be one like this, where I'll give you a trig function, and you'll have to sketch the graph, and you'll have to show all the information. So it says to sketch at least one cycle. Remember, we always show at least one negative critical value. Step 1 is to put it in a standard transformation form. So to do that, we're going to have -2 sine of parentheses plus 3. Now remember, the inside, you're going to have to do a little bit of work, okay? And if you mess this up, it's going to mess up the rest of your graph. We got to put the x term first, and it is, and we got to factor out the 2. So when we factor out the 2, we get x minus what? Well, we have a pi halves to begin with. We factor out a 2 from a pi halves, which is dividing out. What's pi halves divided by 2? Pi fourths, right. Now, here's a quick check, and I've mentioned this before when we've had the other functions. Redistribute the 2 back in and make sure you get 2x minus pi halves. Do you? 2 times x is 2x, 2 times pi fourths is pi halves. Yeah, that way you know you did it right. All right, now I'm going to come over here, and I'm going to list my A, B, C, D, P, and R. Bless you. We're going to do the range as well. All right, so what's the amplitude of this function? What's the wave height? Not -2, just 2. But because it's negative, I'm going to make a note to myself to flip the highs and lows, flip H and L. When we do the Chalem or the Sahala method, we'll just flip the highs and lows. All right, how many cycles do we see between 0 and 2 pi? That's the B value, right? B. Okay, so once we find B, that affects the period. So I always come down and find the period right away. The period, remember, is 2 pi over B. What's 2 pi over 2? Pi. Yeah, so the new period is pi. That makes sense. We horizontally compressed it by a factor of 2, so now we see 2 where we previously saw 1. All right, for the C, I usually put a colon. Is it left, right, up, or down, pi fourths? It's right pi fourths, which is our phase shift. We call that a phase shift. And then the D value, I put a colon. Is it up, down, left, or right 3? Up 3. So you have your sinusoidal axis at y equals 3. SA at y equals 3. Now for the range, remember, to find the range, all we got to do is go to our sinusoidal axis, which is 3, and go down the amplitude amount. What's 3 minus 2? 1. And what's the high point? The sinusoidal axis plus the amplitude. What's 3 plus 2? 5. There you go. So you can get the range pretty easily without sketching the graph. Now that'll help you with your setup. Because here we go for the graph here. We got the y-axis and we got the x-axis. So everything is positive. So I'm going to draw my x-axis a little bit lower than usual because everything's above it. Now remember, we can go ahead and set up the y-axis. This is a 1. The sinusoidal axis is at 3. So we can do that. And then that same distance there, we can call that 5. So there's the low and the high. We could draw in the horizontal sinusoidal axis. So it looks something like that. That looks good. But for the x-axis, remember, all I want to see are the actual critical values, and the spacing has to be correct. So whenever you have a phase shift, you mentioned this the other day, whenever you have a phase shift, you want to make a rough draft x-axis. So here's my rough draft x-axis. Rough draft x-axis, my RDXA. I'm going to come over here to 0, and I'm going to come out the length of one cycle, which is pi. Half of that's pi halves. Half of that's pi fourths. What's my quarter cycle counting interval? Pi fourths. All of my critical values before and after the shift are going to be pi fourths. So this would be 1 pi fourths, 2 pi fourths, this is 3 pi fourths. And then I'm going to put a negative value over here at negative pi fourths. So these are the critical values before a shift. Now, you're only going to be tested through the nice, easy shifts. So it's going to be relatively easy. After we get back from spring break, we're going to look at what to do when the shifts are ugly. Why are they? I say the shifts are nice. We're moving the graph right pi fourths, right? Correct? So if the y-axis used to be at 0, I moved it to the right pi fourths. There's your new y-axis. And negative pi fourths is now at 0. Pi fourths is now at pi halves. We're basically picking the graph up and moving it right one critical value and setting it back down in the existing tracks. Got it? So that's what I mean by an easy shift. So all I got to do now is put my marks on my x-axis. I got 0. And then how far apart do you want to put your next critical value? I'll just call that my next critical value. Now it's incumbent upon you to make sure that the critical values that you draw subsequently are the same distance roughly from each other. And we always have to draw at least one negative critical value. So 0 is still going to be a critical value. That's kind of what's important. Later on, 0, the y-axis, will not be a critical value. All right, now I'm going to draw my new y-axis. It's right here at pi fourths. So there's my new y-axis, and I'll tell you on the test, on the free response, make sure you show your new x and y-axis. All right, now all we got to do is label. Let's just keep counting by pi fourths. 1 pi fourth, 2 pi fourths is pi halves. There's 3 pi fourths. 4 pi fourths is pi. That's 5 pi fourths. 6 pi fourths is 3 pi halves. 7 pi fourths, so on and so forth. You can keep going if you have more points. And then working backwards, we got negative pi fourths. So simplify as you go. I will take off if you do not have your critical values labeled and simplified and spaced correctly. That's like 3 checks on the free response. I'm going to be very, very adamant about that. Labeled correctly, simplified, and spacing correct. All right, now I can come up here and say what's my parent function? Because right now I'm setting the table for either a sine or a cosine. It could be a Sahala or a Chala. Well, it was a sine, it was Sahala. But what do I know because it's negative? What do I do with the highs and lows? I flip them. So let's go ahead and put the dots down. Sine always starts on the axis. So there's my axis point right there. It's the new origin. So it's axis, and now as I go to the right, instead of high, it's low, axis, high, axis, low, axis. And then I work backwards, and it looks like it's going to be a high point and then an axis point. So there's all your critical values. The spacing should be perfect. Then you connect them with nice quarter cycle counting intervals. The graph is going to be worth quite a few points on your test. If you draw these with like ugly straight lines, and I can't tell that you took your time to make it look like a sinusoid, you're going to lose points for the graph, even if they're in the right spots. Okay? So exaggerate the curve. Your axis points should be your inflection points. That's where it should go from part of a smile to part of a frown and part of a frown to part of a smile. Got it? Okay, so there's the graph. You get full credit for a graph like that. I know y'all can do that. All right, now the last thing I'm going to have you do is write equations that are also equivalent to this graph, but are in terms of different functions, positive or negative sign. All right, so here's the next one. It says write one in terms of positive sign. So let's go ahead and do that. Part A, we'll do positive sign. It's still going to be f of x. Is the amplitude still going to be 2? Is the wave height changed just because I'm writing a new equation? Nope. So now it's going to be positive 2 instead of negative 2. It's sine. Are we still going to have 2 cycles between 0 and 2 pi? In other words, is the b value still 2? Yeah, it is. And it's still x plus or minus something, and it's still up 3. Here's the only thing that'll change. Aside from the trig function and the number out front being positive or negative, the only thing that changes is the phase shift. That's it. So all you have to do now is find your favorite Sahala point. Sine is Sahala, right? Sine is Sahala. So if I want to do a positive sign, I need to do a Sahala. I need to look to see where I'm on an axis going high. Where on this graph am I on an axis going up? 3 pi 4. So if you want to shift over to 3 pi 4 to the right, is it going to be plus 3 pi 4 or minus 3 pi 4? Minus 3 pi 4. Would minus 7 pi 4 also work? Yeah. Would plus pi 4 also work? Yeah. So there's three different places where I'm on the axis. There's axis going up. There's axis going up. There's axis going up. So you could shift over to any one of those. All right. All right. Let's do the next part. It says do a positive cosine. So for a positive cosine, we'll do f of x equals. It's positive 2. Now it's cosine. It's still going to be 2. Now it's x plus or minus something something plus 3. All we got to do for a positive cosine is get over to where positive cosine starts. Positive cosine is chala. Now for sine, you have to be careful because you could be on the axis going up or on the axis going down. But for a cosine equation, it's easy. We just look for a high point. There's only one place to go from a high point, and that's down. I spy two high points on our graph. Which one you want to get over to? You want to get over to pi? Good. If you get over to pi, you'll have x minus pi. Could it be that we get over to 0? The easier one, like if this were a multiple choice question, the easier one would just be no shift. It would just be cosine of 2x. You don't need a shift because there's a high point at 0. All right, and then it says a negative cosine. So for a negative cosine, let's see what we get. We get a negative 2. Now instead of a positive 2, negative 2 cosine. The b value is still 2. It's x plus or minus something something plus 3. So again, all we have to do is go to where a negative cosine is. Remember, a negative cosine has the highs and lows flipped, right? So if positive cosine starts high, where would a negative cosine start? Low. All right, where's the low point? Pi halves. So let's just shift over to pi halves and we get x minus pi halves. And it started as a negative sign, but if I have to write a negative sign, another one, I would have to be careful. I'd have to get over to an axis point that's going low. Where's another axis point that's going low? Nope. An axis point going low besides pi 4. 5 pi 6. Let's go ahead and write one. Okay. Let's do a negative sign different from the one we are given. How about a negative 2 sine of 2 x plus or minus something something plus 3. Negative sign is axis going low. That would be minus 5 pi 6. So for sine, you always have to look at 2 points, don't you? You got to be on the axis, and you got to either be going up or down. But for cosine, you only have to look at 1 point. In fact, here's what you could do. If you want to go through this graph and say whether the critical values are positive or negative sign, let's go ahead and do that. Negative pi 4, that would be a positive sign. 0 would be a positive cosine. Pi 4, of course, was a negative sign. Pi halves would be a negative cosine. 3 pi 4 would be a positive sign. Pi would be a positive cosine. 5 pi 6 is a negative sign. 3 pi halves is a negative cosine. 7 pi 4 is a positive sign again. You see what I'm doing there? 1 pi 4, 2 pi 4, 3 pi 4. Yeah, it's 5 pi 4. Why is it 5? Why did I put 5 pi 6? Good catch there. That 6 just kind of stood out like a sore thumb. Yeah, so it should be minus 5 pi 4. Thank you. Bonus points for you today, Brady. Welcome back. I think I was already on the next one in my head as I was trying to catch up with my hand. And I don't know why I wrote down 6. Oh, I know why, because the next one is 6 pi 4. That's why. It was 5 pi 4, then 6 pi 4, and I already said 6 out loud, and my hand was like, wait up, Mr. Brain, I am not as fast as you. Does that happen to y'all? Yeah, it can happen. You can talk faster and think faster than you can write. All right. Any questions on that one? That's your free response question. Can y'all do that? Yeah, absolutely you could do that on your free response. No problem. Okay? All right, let's go to example 9. Sketch at least one cycle, doing the same thing, same exact instructions. All right? So first thing is to put it in the standard transformation form. I got -2 sine of parentheses minus 5. Now, on the inside, I have to factor out a what? Not a pi, but a negative pi. Yeah, negative pi. I'm left with x minus, what do I get when I factor out a negative pi from a positive pi halves? Not -2, but -1/2. Yeah. And again, as you do that, come back and mentally redistribute and make sure you get what we started with. Is negative pi times x negative pi x? Yeah. Is negative pi times negative pi halves positive pi halves? Yes, it is. And 1 times 1/2. Yeah. Okay, now, here's something new that we haven't seen yet. We have a negative b value. Okay? Here's the idea behind negative b values. If you get a negative b value, use symmetry to rewrite it. It's very easy when we're doing the Sahala-Chala method to just switch the highs and lows. But what does a negative b value do to the graph? It reflects it across the y-axis, which would be reflecting it across our new y-axis. That's going to be hard. We'd almost have to like sketch it first and then reflect it. So it's not as easy to sketch a negative b, but we can use symmetry, right? Remember, sine is an odd function. And for an odd function, we can say that sine of negative b is the opposite of sine of positive b. So what do we do with the negative b value? We don't forget about it. We do what? Pull it out front, right? Pull it out front. And then if you ever see cosine, cosine is an even function, remember? Cosine of negative b is the same thing as cosine of positive b. So we have a way to get rid of the negative b value before we graph it. If it's a sine function, we pull it out front. If it's if it's a cosine function, it's not untrue. There you go. If it's a cosine function, we just forget about it. Okay? This one happens to be a sine function. See that? It's a sine function. So what do we do with this negative in front of the pi? Do we forget about it or bring it out front? We bring it out front. What happens if there's already a negative there? It becomes positive. Yeah, and if it were positive, it would become negative. Nice. That kind of takes care of the flipping the highs and the lows. And there's the simplified equation. So you want to do that first. Now let's come down the side and do our A, B, C, D, P, and R. What's the amplitude? What's the wave height? 2. How many cycles am I going to see between 0 and 2 pi? Pi. Every time I ask that, I ask it the same way, because what's the meaning of B? B is not only your horizontal dilation factor, it's the number of cycles between 0 and 2 pi. That's what B is. Now, once you find B, it affects the period. So if the period is 2 pi over B, what's 2 pi over pi? 2. So now it's the first time we don't actually have a pi on our x-axis. It's just going to be numbers. Okay, what's the C value? Left or right? 1/2. Right, 1/2. That's your phase shift. And then the D is down 5. So where's your new sinusoidal axis? At y equals -5. Make sure you write it as an equation. Y equals -5. And then for the range, let's get the range. We start at -5, which is our sinusoidal axis. It's your equilibrium. And then we go down the amplitude. What's -5 minus 2? -7. Good. And then our high point is going to go back to -5, and we're going to go up to, what's -5 plus 2? -3. There you go. That's how you find your range. Now we're ready for the graph, so we'll draw the y-axis, and then everything is negative, so now I'm going to draw my x-axis a little bit higher than usual. All right, we come up here and get a sacrificial x-axis. This is your rough draft x-axis, your RDXA. So here's 0. I'm going to come out the length of one cycle, which is 2. Half of that's 1. Half of that is 1/2. What's your quarter cycle counting interval? What's the most important number on this graph? 1/2. That's how far apart all of your critical values are. So this should be 3 halves, and of course this one should be -1/2. This would be -1, so on and so forth. we're moving the graph right 1/2 unit. So just like before, we're just picking the graph up and we're moving it right one critical value, and we're setting it right back down into the same existing track. See that? Negative pi halves is going to be at 0. So let's go ahead and put our marks over here. Here's 0. It's going to be a critical value. And then I'll put my next mark about right here. And then I'm just going to keep that distance all the way through, eyeballing it, eyeballing it, eyeballing it. And then I need to have at least one critical value, so I'll do that right there. All right, now I just got to label them. What am I counting by? How far apart are these marks? 1/2. Let's see if I can count this time without messing up. 1/2, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves. And then to the left, I get -1/2, -1, -3 halves, -2, so on and so forth. Now, I haven't set up my y-axis. I did the x-axis first. It doesn't really matter. I'm going to come below where my numbers are. I'm going to call this -3. I'm going to come down to the bottom. I'm going to call that -7. And then I'm going to bisect that distance and call that -5. So there is my new x-axis, bless you, my sinusoidal axis. And my new y-axis is at 1/2. So now I have my new origin. My new origin is at 1/2 comma -5. Everyone see that? 1/2 -5. Okay, so now I got to put my marks down. We've set the table. Now I've got to put the plates and the food down. Okay, so it's a positive sign. So it's just a regular old Sahala. I don't need to flip the highs and lows anymore because the negative out front took care of it. So I go to my origin, and there's the axis point. And then going to the right, it's axis high, axis low, axis finishing high, and then working backwards, there's a low point, and then there's an axis point. And then I connect these dots with nice exaggerated quarter cycle curves, and I make sure that it goes from a frown to a smile or a smile to a frown on the axis point itself, on the sinusoidal axis. There you go. There's the graph. Notice everything that is critical to this graph is labeled and nothing more. Ryan, are you on your phone? You're looking like in front of your iPad instead of at your iPad. All right. Once we have this graph, we're going to write an equivalent one, it says, in terms of positive and negative cosine. Okay. So if we're writing the second equation, here we go. Let's do positive cosine. Here's the equation for positive cosine. F of x equals +2, the amplitude's still 2, +2 cosine. The b value is still pi. The only difference is the horizontal shift now. We're still down -5. Look how easy it is. If we're looking for a positive cosine, we're looking for what on the graph? A high point. Y'all see your favorite high point? I see one at 1. I see one at 3. I'm going to shift over to 1, so I put not +1, but -1. Yeah, there you go. And then negative cosine. Here's the negative cosine equation. F of x equals, now it's -2 instead of +2, cosine. The b value is still pi. The only difference is the phase shift. It's still down 5. All right, so for positive cosine, now I'm looking for a what point? A low point. Do you see a low point? At 2, we can shift over to 2. Could we also do at 0 and not have a phase shift? Yeah, we could. We could. I'm not going to write that one. Let's do one more. Let's do a negative sign. Let's do a negative sign. It's going to be f of x equals -2 sine pi x plus or minus something something minus 5. And for a negative sign, we have to look at 2 points for sine. Where do y'all see a negative sign on the graph? 3 halves, right? We're on the axis going down. So let's shift over to 3 halves, -3 halves. You could also have said +1/2, yeah? +1/2, that works too. So there's infinitely many equivalent equations. All you got to do is find one based upon the graph plus that you have shown. All right, one more. Let's do one more. Sketch at least one cycle. All right, step 1, put it in the standard transformation form. F of x equals -4 cosine, parentheses, and then +2. Now notice this one requires a little bit more work on the inside. Is my x term even written first? No. So I'm going to do this in two steps. Negative 3x minus pi. I'm going to do that first. Then below that, I'm going to factor out the coefficient of x. So now I have extra parentheses, and I factor out the negative 3, and I'm left with x plus what? Pi thirds. Yeah. And again, if you're not sure if that's right, what can you quickly do here? Redistribute, okay? And you'll see that you got it. All right, now notice I have a negative b value, don't I? I have a negative b value. I don't want to graph with a negative b. I either bring it out front if it's sine, or what do I do with it if it's cosine? Forget about it. I just toss it aside. So let's go ahead and write the simplified version. It's still going to be a negative out front because we didn't bring it out front, but now it's going to be positive 3x plus pi thirds, close, plus 2. Cosine of negative b is equal to cosine of positive b because it's an even function. All right, that makes it easier to sketch. All right, now I come off to the side here. A, B, C, D, P, and R. What's the amplitude? 4, not negative 4. The amplitude is the absolute value of A, but because it's negative, I'm going to make a note to myself to flip the highs and lows. All right, what's the number of cycles between 0 and 2 pi? 3. That's just your B value. All right, C colon. What am I doing phase shift wise? Left pi thirds. Good. What am I doing up and down? Where's my new sinusoidal axis? So what's the equation of the sinusoidal axis? Y equals 2. I might ask you on the free response to give me the equation of the sinusoidal axis. That would be y equals 2. And then what's the period? The period is 2 pi over b. That's 2 pi over what? 3. 2 pi thirds. Yeah. 2 pi over b is 2 pi thirds. And then for the range, we go to the d value, which is 2, and we go down the amplitude. What's 2 minus 4? Negative 2. And then for the high point, we go to the d value, which is 2, and we go up the amplitude. What's 2 plus 4? 6. There you go. All right, so that's you just collecting your information. Now we're going to come over here and sketch the graph. There's a y-axis, and then most of it is positive, so I'm going to draw my x-axis. You always leave room for at least one critical value on the left, and I'll draw it a little bit lower than usual. All right, let's set up the y value first. Here would be negative 2 right here, and then I'm going to call this 6 right here, and then I'm going to bisect that distance between them and call that 2. And then I'm going to draw my new dotted line. So I will be looking at your spacing as well. Is the distance from the sinusoidal axis to the high and low point, is it roughly the same? If your graph is too tall above it and too short below it, you're not going to get credit. All right, now we need a sinusoidal axis very quickly over here. That's rough draft. So here's 0. I come out 2 pi thirds. That's your period length, 2 pi thirds. Half of 2 pi thirds is 1 pi thirds. Half of 1 pi thirds is pi 6. What's your quarter cycle counting interval? The most important number on this graph? Pi 6, okay? Now I can number the rest of it. This is going to be 1 pi 6, 2 pi 6. This is 3 pi 6, which is pi halves. There's 0, of course. Here's negative 1 pi 6. There's negative 2 pi 6, which is negative pi thirds. All right, now notice I'm moving the graph left pi thirds. So I'm picking the graph up and moving it over how many critical values? 2. I'm just moving it over to the left 2 critical values. No big deal. There's my new y-axis right there at negative pi thirds. So now I can come to the x-axis. I'm going to draw the negatives ones first. So I need to fit 2 of them in there. So I'm going to call that distance right there. I'm going to call that the distance that I need to keep now. And I put another one there, and there's your new y-axis. If you want to call it negative pi thirds right away, that's fine. Your new y-axis is at x equals negative pi thirds. And then this is negative pi 6. Let's go ahead and put the marks down. They're a little bit closer together than I've been drawing it, but that's okay. As long as they're all the same distance from each other, we're good. I'll put one more. And then we label them. I'm counting by what? What's your quarter cycle counting interval? Pi 6. Oh, by the way, if you know that your period is 2 pi thirds and you want to figure out your quarter cycle counting interval, you don't have to bisect and then bisect. You can just take a fourth of the period. What's a fourth of 2 pi thirds? Yeah, you just simplify that and you get pi 6. Okay? So 1 pi 6, there's pi 6. 2 pi 6 is pi thirds. 3 pi 6 is pi halves. 4 pi 6 is 2 pi thirds. 5 pi 6, and then 6 pi 6 is pi. And then I can keep going if I need to. All right, now we put down our points. It's a negative cosine. So if cosine is chala, all I got to remember is to do what with my highs and lows? Flip the highs and lows. Yeah, so here we go. It starts at a what? Low point. So over here at negative pi thirds, I put a low point, and then it's an axis point, and then it's a high point, and then an axis point, and then a low point, and then an axis point, high point, axis point, low point. Notice how I put my low point below the marks on the x-axis. I did that intentionally. All right, now I just connect it with nice quarter cycle counting intervals and make sure that they're curved. If you do it in quarter cycles, you're less likely to make a bad graph. Okay, you're exaggerating the smiles, you're exaggerating the frowns. All right, then all we have left to do is write equivalent equations. It says in terms of positive and negative sign. So here's positive sign. We get f of x equals positive 4 sine. The b value is still 3. The only difference is now it's x plus or minus something different, and it's still plus 2. So as you've seen, we've been doing the same thing. All I have to do for a positive sign is get over to which point? Sine? No, sine always starts on an axis. An axis point. Could it be any axis point? I got to be going up. I see 2 axis points going up here. Negative pi 6 and positive pi half. Does it matter which one we get to? No, I'm going to get to the negative pi 6 since we haven't gone left here. Is it going to be plus or minus pi 6 if I need to go left? Plus. Good job. You could also say minus pi halves. All right. And then the negative sign, let's do f of x. This would be negative sign. That's negative 4 now instead of positive 4. Sine of 3 parentheses x plus or minus something something plus 2. Now for a negative sign, I need to look to see where I'm on the axis going where? Low. Where am I on the axis going low? Pi 6. So I'll put minus pi 6 or minus 5 pi 6. How far apart are pi 6 and 5 pi 6? How far apart are pi 6 and 5 pi 6? 4 pi 6, which is what? 2 pi thirds. Isn't that the period? It's exactly 1 cycle away, which is the period length. All right, there you go. We finished in time. That's where your test is going to be. Tomorrow, your homework is not going to be due because we didn't finish this section, but you want to make sure you do enough of your easy homework problems that you can do well on the test. Tomorrow, I will have a practice test for you to do in class, and it'll be due on Wednesday at 9 a.m., and we'll test on Wednesday. Okay? Sound good? These are the easy shifts. They will get harder after this test. They will get more fun.